A very good evening to ladies and gentlemen present over here. Center of Excellence in Safety Engineering and Analytics, IIT Kharagpur welcomes all the participants to this 14th weekend talk of Safety Engineering and Analytics. So yes, भारत सरकार ने आज़ादी के जश्न के लिए आज़ादी का अमृत महोत्सव कैंपेन को लॉन्च किया है. इसे मिनिस्ट्री ऑफ कल्चर द्वारा आयोजित किया जा रहा है. तो ये वीकेंड टॉक उसी की कड़ी में आईआईटी खड़गपुर द्वारा आयोजित किया जा रहा है. असतो मा सद्गमय तमसो मा ज्योतिर्गमय मृत्योर्मा अमृतम गमय. So with this prayer of leading from darkness to light, from the unknown to the known, and from destruction to immortality, we initiate our 14th weekend talk. With this, myself, Mom Mitra, with our co-moderators, Sinjana, Sovik, and Ashish from IIT Kharagpur, welcome you heartily to this session. So, there is an announcement, ladies and gentlemen. There is an international conference on maintenance and intelligent asset management. So, all are requested to submit the abstracts. The deadline is 10th of September 2021. Notification of abstract acceptance will be done by 20th September. Paper submission deadline is 15th October. And notification of paper acceptance date is 30th October 2021. So all are requested to please submit more and more abstracts under this subject. So now we formally welcome our dignitaries to the dais. We'll request them to put their videos on. Professor J. Maiti, Chairman COE-SEA, Professor O.P. Krishna, Convener of the Weekend Talk Series, and Professor Ashish Bhattacharjee, our expert speaker of the evening. Thank you, sir.
Thank you.
So, Professor Ashish Bhattacharjee is a professor of the Department of Mining Engineering and Joint Faculty of COE-SEA of IIT Kharagpur. He was the head of Department of Mining Engineering during 2003 to 2006. He received his bachelor's degree in 1980. He was awarded the MS degree in Operation Research from Florida Institute of Technology. He was also awarded PhD in Mining Engineering and Operations Research from the Pennsylvania State University. Dr. Bhattacharjee was a postdoctoral research fellow at the Pennsylvania State University during the period of 91-92, and he investigated several NEOS projects. He has investigated several externally funded projects in India, USA, France on occupational health and safety, injury epidemiology, and operational research over the past 35 years. So he guided over 75 graduate students, including 10 doctoral students. Dr. Bhattacharjee is the author of over 140 research publications in technical journals, conference proceedings, and he is also the co-author of 20 technical reports. Dr. Bhattacharjee has served as a member during the past 20 years in several committees of the Ministries of Government of India, and his current research interest includes occupational health and safety in mines and other industries, injury epidemiology, safety analytics, mine management, and operation research. So, ladies and gentlemen, let us keep our hands together and for a very, very interesting topic, assessment of the effect of whole body vibration exposure of machine operators to MSD using analytic epidemiology. So I will request our chairman is COE-SEA, Professor Maiti, to formally welcome our expert speaker. Over to you, sir.
Thank you, Mom. So what I can say about Professor Ashish Bhattacharjee, he was my supervisor when I did my PhD, and I completed my PhD under his supervision in 1999 in the area of mine safety. I came to know how operations research techniques and statistical modeling can be applied in the safety management domain. And during that time, all the today's machine learning techniques, what we are talking about, or we have been talking about, like logistic regression, like a correspondence analysis, like structural equation modeling. So in the 90s, late 90s, I think 1995 to 1998, with the guidance of Professor Ashish Bhattacharjee I am fortunate enough to apply all those techniques in my PhD work. So he is not only an scholar, a scholar from the academics as a research point of view, but he is an able guide, a supervisor par excellence. When I joined IIT Kharagpur in MTech, and I was again fortunate enough to be to do my MTech thesis under him. That time I'm openly, frankly speaking to all of you, you all will be happy to know that I was not able to write the technical part of it, how to write the technical writing, lot of mistakes, full page correction, only red color. And he basically put me in his room and say, okay, you do, I'm correcting and guiding you. So I owe a lot to Professor Ashish Bhattacharjee, sir. I am really so much thankful, grateful to you because I learned whatever I have learned from you, I have just tried to use afterwards. Obviously, the things are time progresses, lot of new things comes, and you have the uncanny knack of adopting all those new tools, techniques, methodology in your research, and that way you are helping us also even after so many years of PhD. So I don't want to extend my talk about you now because it will be more than few hours. So with this brief note, and you are part of COE SEA, so I'm really so much thankful and so much pleased to welcome you for this weekend talk. And you are
Thank you.
talking about a new topic, and I'm sure the participants will be very much benefited from your lecture. And Sir is a very fluent speaker, a very good orator. You will definitely understand after his speech today. So I welcome all the participants, and I am requesting Professor Bhattacharjee, my supervisor guide, to start his lecture.
Thank you, Dr. Maiti, for your kind words. I don't know whether I deserve those things or not, but I had a pleasant opportunity working with you for 6 years, in 90s. So definitely that was also my starting point. And in fact, for information of all of you, Dr. Maiti was my first PhD student.
Oh, that's great.
Yes. So I was lucky. So I opened my PhD thing with Dr. Mike. So I'm lucky so many ways. And today also I'm benefited. My scholars are benefited. So with these few words, I express also my thanks to Professor Krishna and Mom who are present here, who will be, guiding me through this entire program. Okay, then Souvik has helped me a lot throughout this last week to have everything going smoothly for today's presentation. Thank you, Souvik.
Thank you,
So today I'll be talking to you one of the hot topics: assessment of the effect of WBB of exposure of machine operators to MSD using analytic epidemiology. So you may be heard another term of WBB exposure, which is also known as human vibration. And this is not only applicable to mining operators, this is also applicable to any machines like tractors, in construction sector, the various machines they operate, various vehicles and all that, and also they operate various hand-on tools. So today I will share with you, of course, being working in this area of analytical thing, data analytics. So I will also share with you very briefly, about application of this work which we did for Tata Steel. Let me tell you, we are doing this work during the last 10 years. And slowly and slowly we have developed this field. I hope you can see now. Okay, my next screen. Now, mining operators. Of course, I will talk about mining. As you know, it is our work is mostly on mining, but it is applicable to any sector. Just before we started our this thing, we can talk. I was just sharing with Professor Krishna. He informed me they wanted to do it, in the maintenance this thing department. So mining operators of heavy earth moving machineries, such as dozers, dumpers, shovels, and drills, okay, are exposed to whole body vibration during the production process of surface mining operations. Okay, so all right. Then hence action plan should be given to give proper consideration to human vibration during the planning stage for acquisition of new machines before their introduction of mining operations. Now, why they are so important? Because it relates to all kind of, musculoskeletal disorder problems. All right. In fact, when we do or made a field visit to Tata Steel and talk with many of the operators, they shared with us that they are suffering all kinds of pains, and in fact, some of them they get crippled, if they are exposed to this for a long time, particularly in the uranium mines, where it is a hard rock mining and there's a huge vibration. Hence, action plan. Okay, then U.S. Department of Labor. In India, we do not have, unfortunately, no statistics, but U.S. Department of Labor classified mining as one of the most hazardous occupations in terms of economic exposures, which is measured in terms of, in U.S. anything is measured, whether it is injury rate or economic thing, incidence rate of work-related musculoskeletal disorders is 30 per 10,000 workers. So a country like US, where they have everything, they have advanced technology, the working condition is very good. Even then, it is one of the major problems for the US mining sector for, surface mining. And by the way, let me tell you, now surface mining accounts for almost 90% of the global production in gold as well as non-gold. Okay, except in US, from underground mining they produce 40%, and open cast they mine or extract 60% of the gold. Whereas in India, whether it is gold, metal, non-metal, over 80%, is, 90% the production is coming from surface mining. So you can see the importance of surface mining and the health and safety effects in surface mines. Human exposure to vibration, which is also known as human vibration, is classified as one of the physical occupational hazards in the workplace. If you have any question, we'll obviously take up later on. Now, in this direction, the DGMS, Director General of Mine Safety, the regulatory body, which is located in Dhanbad. Some of you, I know very well, Professor Maiti knows it very well. So they are basically the regulatory body, and every 3 to 4 years interval, they conduct this National Safety Conference. And this 11th National Safety Conference, it was held in Delhi, and I get invitation for all these conferences because I have a very good, contact, or rather I should say I am in touch with them since I came to India, in 1992. So in 11th National Safety Conference 2013, they came up with a recommendation, all right, which they say in the 11th Conference Safety, which was held in New Delhi, Directorate General of Mine Safety has recommended that vibration studies of various machines before their introduction in mining operations should be done as per ISO standards. Okay, so that is the first point, that every equipment which are being installed at a mine, or also for existing, all the equipments which are running and which are causing problem in terms of vibration because of the complaints given by the operators to the management, this vibration study should be carried out, and it should be within the limit of ISO standards. Unfortunately, let me tell you, during the last 10 years, we have conducted studies in several mines of uranium, mines of chromium, mines of iron ore, mines of coal, all kinds of mines. Almost all the mines, the equipment operators exceeded the limit, the lower limit of ISO standards, which I will go through in my next few slides. So ergonomic, and the second recommendation is that if it exceeds the ISO lower limit, then ergonomic assessment of all latest machines before their introduction into mining should be carried out, which includes assessment of work process, then assessment of working aids, tools, and then assessment of working posture. So, as many of you are familiar with ergonomic, this thing field, so you are familiar with all these things, that we carry out not only for the health aspects but also for safety aspects. All right, this is what I wanted to project, even though it is not connected with my today's, yes, it is connected with today's topic, but to make you aware of, if some of you do not know, you can download this app, this International Social Security Association. I'm an active member of ISA, their headquarter is in ILO, the headquarter of ILO, and they're mining. They have 13 prevention sections, and mining is one such prevention section. And in 2010, the mining division proposed this golden rule, 7 golden rules, for an effective integrated health, safety, and well-being of workers system. Okay. And eventually it was taken by or accepted by all the 12 sections. Now they are in touch with, they are working hand in hand with ILO to ratify this, so that ILO can also accept this, as the approach to go ahead with. And for your information, our government of India has also accepted. In fact, Ministry of Labor, they have accepted this, and it is being implemented in the factories aside. But mines division, it has yet to find its application, and they have approached to us so that we can be a nodal agency in India to propagate this ISA 7.0 concept to mining. Now it has got 7 rules. I will just quickly go through them. I will not go in detail, but I will just say them. Commit yourself to leader this system. The leaders, corporate leaders, mid-level management, lower-level management, they should first be committed to safety. Second is identify hazards and risk in your activity. This is a HERA. This is a mobile-based app. You can download from Google Store. If you just say, ISA 7 golden rules, immediately it will be downloaded, and then by giving your name and organization, you can have full access to the 7 golden rules. And you can assess your workplace or anywhere you are there. Okay, the third rule is set safety and health targets. This is basically setting the lagging and leading indicators. Then ensure a safe system, the system which you are using, that should be safe. Fourth rule is use safe and healthy technology. For example, we have this increased automation lately in all the mines. Okay, in all the mines we have this increased automation. But at this technology which we are importing, and the equipment or machines, they are mostly imported, from outside. Like the US is the major supplier, like Caterpillar. They are the major supplier of dumpers, dozers, shovels, all kinds of things. All right. Then Komatsu is another one, Japanese company. They are supplying also different types of HEMM. Improve qualification, that is improve qualification of workers, and involve your worker. So the worker should be involved, to have this integrated safety and health management system works effectively. Now this you cannot see the screen possibly, but under this use safe and health technology, under the 7 golden rules, they have a question, which one it should respond at their mine or at the Tata Steel headquarters. Those who are procuring equipment, do you take into account safety, health, at work subjects, when making a request for new equipments or machinery? As far as I know, they, when they quote any equipment or they want to float a tender, they don't specify anything about whole body vibration. All they are concerned with is the machine vibration. But through this study, we could convince the R&D division of Tata Steel headquarters that it should be done. So lately they are also doing, they have gone through our report of West Bokaro and Noamundi, and they feel that this vibration study should be a part while they are floating their tenders. All right. Okay, so what is this human vibration? Human vibration is separated into 2 subcategories. Hand-down vibration associated with the use of vibrating hand tools, and the whole body vibration, which is also known as human vibration, associated with HEMM operators such as dumpers, dozers, graders, and this thing. And this is when they are operating, heavy vehicles, and where they experience heavy vibration. The long-term exposure to whole body vibration of HEMM operators is associated with various health issues. However, there is a lack of information about these in mind. So far, awareness is slowly building up because of the DGMS recommendations, and also the recent coal mines regulation, which is being enacted from 2007, where they have mentioned a few regulations related to, the ergonomics perspective. So these are the 2 things. One is hand-on, another is full body. So motivation of this study, this was a study, as I told you, we conducted, for Tata Steel mines. Exposure to whole body vibration is an emerging. In fact, they approached to us, because of the severe complaint from some of the operators the management was receiving regarding different pains. Exposure to a whole body vibration is an emerging issue for the mining industry and inherent to many mining operations. These vibrations are caused by accelerations produced by heavy earth-moving machines during its operation and are transmitted to the machine operators through the seat or the feet. So we can measure both this, seat as well as feet. So we need to have a six, the send this thing, the channels to measure the vibration both at the seat pad and also, or at the seat and also at the feet. Heavy level of exposure can lead to health risks, which are more important when vibration magnitudes are high. The exposure duration is long, frequent, and regular, and when the vibration includes frequent shocks or impacts. So all these things are present, in for mining equipment as the operators they are in service for 20 years, 30 years, and even some of them they are working more than that. Okay, so these are the various health effects of vibration. Low back pain, this is the major problem. Spinal degeneration, neck problem, NIOSH, they came up with several studies through which they found this. Muscle fatigue, then sleep problem, headache and nausea, then hearing loss, and then gastrointestinal tract problem. Okay, so all kinds of problems may take place. So this you can see musculoskeletal disorder problems from WBV, for HMM operators in mind. So all kinds of problems, back pain, neck pain, leg pain, all kinds of problems. So this may be, it's not visible for you to study. Globally, across the globe, several studies are going on in surface mines. Okay, most of them are surface mines, because in underground mines, particularly in coal mines, if it is gassy, then regulatory bodies usually do not give permission to have these machines underground. Like in India, so far we do not have any permission, but we can do this study in surface mine. So if you look at, during the last 20 years, several studies have been done, mainly during the last, decade. Okay. And the vibration later on, we will see it is measured by, it is measured by A8, which is, the vibration for a duration of 8 hours. And based on the ISO limit, their health risk, you can see it is given there. And similarly, the vibration dose value, which is the cumulative dosage the operator is receiving if they are working for 7 hours, or even some of them are working at a stretch for 8 hours. Okay, so this is the picture. Okay, so summary of vibration exposure limits and guidelines for 8-hour duration. This is ISO 2631-1997. This is for human vibration or whole body vibration. And again in 2010, they came up with an amended version where they put up the limit for vibration dose value. So if the lower limit, if it is less than 0.5, vibration is measured, as I mentioned to you, is frequency weighted root mean square acceleration. Okay, so if the measured vibration value through the vibration meter is less than 0.45, then there is no evidence. Now when I say evidence, we have to keep in mind all these evidences are being established through epidemiological studies, but there is no one-to-one correspondence, between the exposure to vibration and the various health effects of vibration. So till now, there is no such findings have come up from the medical side or pathological aspect. So the lower limit is 0.45. Then, they are exposed to moderate risk with the orange color when it is 0.45 to 0.9, and the exposure is very, very high, and they should immediately take action, when the exposure exceeds 0.9. Similarly, the vibration dose value exposures are given. The lower limit 8.5, the in between 8.5 and 17, they are exposed to moderate vibration dose, and if it exceeds 70, the shock components are much high and all that throughout the exposure, then they are at very high risk. So whole body vibration standards, I should not spend much time on this, covers the methods for measurement of periodic, random and transient vibration with regard to health. The considered frequency range for WBV is 0.5 to 80 Hertz. The reason being the fact that 0.5 to 80 Hertz, because most of our body parts vibrate within this range. Okay. So we have to have a natural frequency, which the body parts are vibrating. And then we have a frequency, the vibration which is being transmitted, okay, from the equipment through the seat pad, the accelerometer which is being put on the seat pad, the seat rather, not seat pad, this thing. So basic methods of measurement are frequency weighted mean square acceleration and vibration dose value, applicable for vibrations transmitted to the body as a whole through supporting surfaces, the feet and the back and the feet of a seated person, or the buttock and supporting this thing. So this is a person sitting, and this is, the X direction is the direction where their driving wheel is there and they are looking in front. Y direction is the lateral direction and Z is the vertical direction, okay, along the spine by vertical direction. Okay, and the evaluation methods, as I told you, there are, two evaluation methods are there. One of them is frequency weighted root mean square acceleration. Another is vibration dose value. So whether we have to measure only this or we have to measure both, this will depend upon the crest factor, which is very, very important, which we have to measure for any equipment operator when they are exposed to vibration, which is maximum of the acceleration during the time period, the period of measurement, what is the maximum, and the average, root mean square acceleration. So this ratio, is very, very important. If it exceeds 9, okay, then we have to measure both frequency weighted and vibration weighted. However, if it is less than 9, then we are only, happy with measuring RMS, root mean square acceleration. Okay, so this slide also may be very small. It may not be visible. So as I talk to you, there are two measures are there. One is frequency weighted RMS acceleration and, VDV, frequency weighted RMS acceleration and the VDV. Oh, I'm sorry. Something wrong. Okay. Operated by. I'm fine. Okay. So, and then this is the 8 value, that is the, the frequency weighted RMS acceleration for a total shift period of 8 hours, okay, which is given by AWD, then square root of, TE by, time of the total time of the shift, okay. T is the exposure duration. T is the exposure duration. And similarly, we can calculate the vibration dose value for a period of 8 hours, which is, VDV, then, multiplied by then square root of, T exposure by T, this thing, the total period of this. Okay, so now we will slowly approach to health and safety data analytics. Little bit, it applies to very two powerful statistical techniques, data mining. It models relevant previous data and then we can do trend, pattern, relationship, and prediction also. So all kinds of things which you all are familiar with. There is nothing new in today's mining industry due to automation. It is not only because of industry 4.0, but today in mining, the automation and digitization has come up in a big way before this industry 4.0 came into effect. The huge amount of data directly or indirectly related to health and safety are being generated and collected. As a result, a large amount of data piles up on a regular basis, and which is difficult to handle manually. In fact, unfortunately, in Mines division of Tata Steel, they are not handling this huge data which are being generated through any aspects, particularly, this vibration study with the data which are captured through sensors. Though data is available, not enough analysis is being done to create meaningful information to assist in decision-making process related to enhancement of safety in mines. Okay, so this is what it is. Okay, this you all are familiar with. Just we have drawn, for those of, the the people or officials, who are not aware of any data analytics thing and all that. So we have this data, then we apply the knowledge, which, and through this knowledge we draw different, the data analytics, starting from simple descriptive statistics to the different kind of advanced statistical models like logistic model, then the log linear model, structural equation model, to find out the causal relationship, and then finally we take actions. Okay, so this is what very important slide for us. So there are the types of data that we collect whenever we carry out any this thing is the vibration data. We also carry out, we also measure, we also measure the ergonomic related data, we measure the machine related data, and we measure the personal data. All right, then we do data analysis. We can use several software packages, or we can use R or Python code to do this. And then finally the knowledge which is being generated, we draw different kinds of graphs and all that, pie chart, bar chart, all those things, and then eventually the action. Okay, so these are the factors which influence WBV for mining equipment operators, because in puts it can be applied to all the same thing. So we have personal factors, as I mentioned to you in the previous slide. We have ergonomic factors, we have mining related factors, and we have machine related factors that finally lead to what related musculoskeletal disorders. So we have to address or identify the the cause and effect relationship of vibration of this, which eventually lead to work related musculoskeletal disorders. So this is what, as you can see, the various factors, the causal factors that we consider. Even we have considered for Tata Steel mines also. The personal factors, we do not go too much of factors, like our main factors which influences vibration based on literature search, we take it. Age of the operator, which is very, very important. As the operator becomes older, then they will have a more MSD problem and those things. Then weight of the operator, which is very, very important. If they are bulky, then they cannot take up, erect posture, okay, which they should be taking, when they are sitting in their seat, okay, the operator seat. Then machine related factors, age of machine, load versus no load condition, then average speed of dumper. Okay, this is very, very important. What is the speed at which the dumpers are flying? Okay, so we capture all the speed and all this, from the GPS data that we collect from their fleet management system, through which we make use of for different purposes. Ergonomic factors, the main important thing, we measure the awkward posture. That is the dynamic posture as well as the static posture. Okay, we measure all kinds of awkward posture and we take into consideration in our analysis. And then inappropriate back rest height, which is very, very important. This is from the sit design point of view. Okay, because if they're the anthropometric body dimension does not match with the dimensions of the seat, then it leads to lot of awkward posture, ends up with awkward posture the operators they do to take. And the mining factors, the most important factor we consider for dumper operators, and specifically those equipment which are moving, like dumper operators, then dozers, then graders, then rollers, the movable equipment, then we also measure their poor haul road condition, because this is very, very important. So this is what the epidemiological approach we have taken. I should not get into all general things, but we should keep in mind epidemiology initially was concerned with epidemics of communicable diseases like dust, TB, cholera, all those things. In 1960s, this field was started. Then it was extended to non-communicable diseases. Okay, today epidemiology is applied during the last 20 years. They are looking at behavioral factors, individual factors, including health factors related to safety and health issues. Then there are three types of study designs out there. When we talk of the study design, we have a collaboration with the French National Institute of Health and Medical Research. Their team, they help us, we collaborate with them and get their benefit for us, for the design aspect of the study. Prospective cohort study design, retrospective test control study design, and the third one is cross-sectional study design. This can be applicable to study any disease or any type of injury. Prospective cohort study design, this is, as I told you, particularly for communicable diseases like, when we set up DAS standards, or when we say, cigarette smoking is injurious to health, we carry out this type of cohort studies. So a prospective cohort study is a study in which a cohort of subjects with exposure and without exposure is observed for a specified duration. The number of subjects that develop injury/disease, of the interest is noted. And this is also known as longitudinal study, okay, through which we can establish the temporal relationship, that is the cause and effect relationship. A retrospective case control study is a study in which two groups of individuals are identified. A group that has faced a disease, like in this case, the different MSD problems or injury, they are known as a case group, and a group that has not faced any disease or injury control. So in this study, we have carried out this case control study. We have chosen all the dumper operators in the mine, and the controls are the office workers, maintenance staff, and all that, who are not exposed to violation. And in cross-sectional study, basically, we randomly pick up the subjects, and then I divide them into two groups, the injured, non-injured, and then try to look back. But through this cross-sectional study, we cannot establish cause and effect relationship. Okay, field investigation. As I said, I will talk about an application aspect of this theoretical thing. And so field investigation, we carried out this study for Noamundi as well as West Bukharo mines. So this is for Noamundi and Katamati mines I am projecting, which we carried out very recently. WBB exposure measurements were performed according to the standard procedure described in ISO 2631-1997 and also 2010 guidelines. A triaxial seat pad accelerometer, the model we use, it is for NOR 133-1286. It is a we have three non-sonic instruments. One of them is NOR 133, which is a 3-channel machine. Another is NOR 136. It is a 6-channel machine through which we can measure the vibration at the seat pad as well as at the feet. Was placed on the machine in accordance with the 2631-1937 guidelines with regard to direction and anatomical position. As I mentioned to you, the direction towards the operator where the driving wheel, it is known as the x-axis, lateral dimension is the y-axis, and the vertical one is this. Then measured in 3-axis coordinate system. This what I told you. This was carried out in NOR 133, but then eventually we switched over to NOR 136. In the study, in order to get a representative vibration, measurements were taken for a cycle. And in fact, we have taken, 6 cycles, which basically covered the entire ship. It was a painless job, which was carried out by my study team and research scholar. Okay, and that's sitting next to a dumper operator and conducting this, taking down notes of vibration. The study included 65 cases and 65 controls. The cases were dumper operators who were directly exposed to machine-induced vibration. The controls were workers who were never exposed to vibration from the same mines. They had been employed as a weighbridge operator. Then service assistant, then draftsman, then office staff, then for who are involved in planning, purchase, maintenance department staff, and at the survey office. They were working in sedentary office job in mines with an average working length of 10 years. Okay. So study protocol requested consists of a request for participation of subjects and the data collection through face-to-face interview, because most of them are not literate. So we had to carry out face-to-face interview during their break period. Okay, as most of the dumper operators could not read and write. The mine management was informed, and they were obviously, it was a thing approached by Tata Steel. So obviously we got full cooperation from data, and all types of data were shared to us. For most of the workers, the interview was done, as I mentioned to you, during the break. Then analytical epidemiology was used to analyze MSD block. Okay, this is the instrument. I will not spend time. This is the whole body vibration meter, and this is the seat pad accelerometer. Okay, 6-pad accelerometer, and which operates, using piezoelectric sensors which are there. All right. Okay. Then WBB exposure of some dumper operators in mines. Actually, we'll talk about. Yeah. So this is the Noamundi mine and Katamati mine. Those who have visited, I understand Professor Krishna has visited this mine. I'm not sure whether Dr. Maiti could get an opportunity to visit this, or maybe he has visited also. So this is a 100-tonner Komatsu dumper. Okay, this is a 100-tonner Komatsu dumper. They have purchased these equipments in different installments. In 2005, they purchased one lot. 2011, they purchased one lot. And also in 2016 or so, they purchased another lot. And as our study was very new, so we could get all types of dumpers. Some are very old, some are very new. So this is what, it is not visible. but this is the output of our, from the instrument. Okay, from the instrument, that is the data automatically gets captured. Then we download this to our laptop or a desktop, and eventually running their software, we can get all this data. So we have divided the whole dumper cycle time in different divisions. Like this is what the loading time, loading time, including the waiting time to queue. This is the vibration data which is being captured. This is the the amplitude of vibration in terms of root mean square acceleration. That is what it is given here. Frequency weighted root mean square acceleration, and this is given for a period of 1 second. Now this vibration meter captures data at interval of 0.037 minutes. So you can imagine the volume of data that gets collected. Okay, so this is in the y-axis, the lateral direction, and this is in the the vertical axis, or the the along the spine. So if we look at these 8 values, so through the GPS data, we could segregate these times, and then using the software, we could again get the average RMS value during each of these, the activities during an entire cycle. And this is what the loading time, loaded travel time, when the vibration is close to 0.534. Then this is the waiting time and dumping, where vibration is reasonably small. Then we have the empty loaded time. Again, here also you can see vibration is very, very high. So if you look at this RMS acceleration, you can see the Z direction is the dominant axis. So it will cause more health effect in the Z direction than X and Y direction. Okay, so this is the mine pictures. Those of you have visited, you have seen. This is in a hilltop deposit. Okay, this is the haul road condition, or through which the dumpers ply. Okay, and they are at a far off distance from the from the production area, which is somewhere down to where they dump the material. Okay, whether it is a waste dump or a iron ore dump. Okay, this is the 100-tonner Komatsu dumper. This is a operator sitting there. You can see, so if you closely look at this, they are not taking, proper postures, like their back is not supported by the backrest height. So all kinds of problems, and they are taking a awkward posture. You can see their body is inclined, so it is not taking a erect posture, so that the vibration is less. So these are the data. Again, it may not be so visible to you, but I will tell you, this is the 8 data. Okay, 8 is basically, as I said, the frequency weighted RMS acceleration for a daily exposure of 8 hours. The average value was 0.48. Okay, average value was 0.48, and this is for 65 dumpers. All right, this is for 65 dumpers, and these are called the descriptive, analytics or descriptive epidemiology, where we generate descriptive statistics, mean, median, mode, skewness, and all that thing. So all these values are given there, and when we look at based on ISO lower limit, you can see, this 8 value, which is basically along the dominant axis, that is the Z axis. The 41.5% of the operators, they are below the, they don't have any health risk because their value is 0.45, less than 0.45, whereas around 60% of the operators, they are exposed to moderate health risk, and of course, nobody is exposed to very high health risk. Similarly, the VDV, vibration dose values, the cumulative doses, and finally the trace factor values. If you look at in the Z-axis, it is very, very high. Trace factor where it should be less than 9, whereas the mean value of 65 operators is 15.1. 0, and almost all, not almost, 100% of the operators, their trace factor is exceeding, the upper limit of vibration, the vibration, the dose value. This is the, based on Nordic questionnaire, we prepared a questionnaire format, and we collected this data. Not only we verified it from the occupational physicians, but collected this data to questionnaire survey to the operators. So out of the 65 operators, 70% of the operators we found they are suffering from some type of disorders. In fact, some of them are suffering from more than one type of disorder. And the most significant one is the back one, okay, back pain, which is lower back, which is indicated by the red color, followed by the orange one, okay. The orange one is indicated by this one, that is, the, I think, elbow pain, and then of course neck is there. So these are the three things, which contributes for almost more than, the 70% of the vibration, or maybe 80% of the vibration of those, operators who are suffering from some. This is for the control, because we have chosen also office workers. There we found out, only 40% or so they are suffering from some type of MSD problems. And again, of course, they have a problem of, back posture, because all the time they are sitting in an office chair, and mostly they take a awkward posture. And this is what the picture is. So I will show you the statistics through which you can very clearly see. So we have divided the different body parts: neck pain, upper limb, and shoulder pain. These are the things, and again they are broken down into shoulder pain, upper limb pain, and this is based on Nordic questionnaire output that we got. Then upper back, lower back, knee, and leg. Again we have broken down. Again we have divided based on age group, cases, and controls. Then we have looked at, more than 10 years with the job, where 52.3% in the cases, whereas 26% in the control. Similarly, we have also taken their height and the body mass index. And this p-value we have generated through a two-dimensional contingency table. Those of you who are familiar with, we use this, to compare whether the cases and controls in terms of this musculoskeletal disorder are significantly different or not. And the values less than 0.05, we call it significant. So that way you can see the knee and, this knee and leg pain is significant, lower back is significant, upper back is significant. So all these values, again, upper limb pain is significant. So all these values which are less than 0.05, they are statistically significant. Similarly, we looked at age-wise distribution of that. Okay, so this is what then we carried out logistic regression. Okay, then we carried out logistic regression to find out a causal relationship between the risk factors and the, but before that, this is not the one. This is where we are showing, here the dependent variable is the different type of disorders, okay, different type of disorders, and the independent variable is, the cases and control. So both of them are binary in number. So cases and controls. So this is what is the table. We calculate the odds ratio. And now we have adjusted this for age and overweight. So individually, we ran this model for neck pain, taking into consideration also age, overweight, and then, obviously case and control, that 1, 0 will be there. Now, as this is a binary variable, so we have to end up taking, logistic regression model, okay? Logistic regression. And this is what you can see, the adjusted odds ratio. That's what we have calculated. Odds ratio at 95% confidence interval. This is the crude one, and this is the adjusted one. So we ran for age for a 10-year increase. All right. So 10 years, 10 to 20 years, considering a reference age, whatever is the age, the 18 years, if it is the entry or how long they are there, based on that, we found out this. Okay. And the significant things are marked by this one. So obviously you can see upper limb and shoulder pain. They are significant for increased age and for increased overweight. Okay. Oh no, this is not significant. Similarly, we could find that lower back pain, upper back pain, it is significant for increased age and also for overweight, lower back pain is a problem. Then adjusted odds ratio, when we take up, all these factors into the model. Okay, all these factors into the model, we get the adjusted odds ratio and 95% confidence, where we find age for a 10 years in this thing increase. The upper limb is statistically significant, then upper back pain is statistically. So how do we interpret this? For example, upper back pain or lower back pain, for the dumper operators, that 10 years increase in this thing, that the increase in age. Okay, increase in age, their chances of injury, compared to the those who are not suffering is 2.16. Okay, so this is what is the adjusted odds ratio. Then this is the cumulative number of musculoskeletal disorders. So here age for a 10-year increase, overweight, this thing. Here cumulative means only only one type versus 0. There is only one type of back pain problem, or 2 or more types of back pain problem. And this is what we carry out, the musculoskeletal disorder for the using the adjusted, or this is of course adjusted because we had to take into, no, this is not adjusted, this is the group, but this is adjusted output, where our independent variables are age, overweight, and the dependent variable is the the dumper operator suffering from some type of disorders, musculoskeletal disorders. So one of the major causes is the ergonomic. I will quickly glance through this, and as you all are, or most of you are familiar with, so so because as I said, ergonomical issues are one of the major factors beside the other factors which are there, and we carried out static as well as dynamic, the body posture assessment. For dynamic, we used, the REBA, rapid entire body assessment, and for, static body posture, most of you are familiar with, we measure through, anthropometer. Okay, so it is the one through which, and this helps us through this, static body posture, whether the operators are matching with their seat, even though all the dumper are ergonomically designed as claimed by the the equipment supplier, but we find when we consider the body dimension of the Indian workers, they are usually comparatively shorter compared to an European worker or an American one. Okay, so obviously, as most of this equipment are supplied either from Europe or USA or from Japan, it is related to their dimensions. So two types of, as I said, static and dynamic. So we measured, anthropometric measurement of the dumper operators. So some of the important measurements we have taken: the sitting height erect, sitting height normal, this is given in centimeter, then knee height, population height, those you know what is this population height, from the floor to the, where the buttock, the periphery, what we have, okay, population height, then buttock knee length, then buttock population length, and the buttock width. So all these dimensions were measured, the mean value, standard deviation, maximum value, so on and so forth. And then we compared with the sit dimension. Okay. Then we compared. So sit dimension, for example, seat height, in a erect position, it is only it is 79 centimeters. So when we look at anthropometric measurement, we find 5% of the operators, they have a dimension of 72.88, whereas 95% of the operators, they have a dimension of, sitting height, erect posture position, the backrest height, erect posture position is 88 point this thing. So you can see this is much, much higher than the maximum backrest height or the seat height of the seat. Obviously, they will not be able to rest their head, which will lead to their neck pain problem, and they will not be able to take a proper posture. Similarly, the length of the seat, of course, it is mostly within the limit. There is no problem in general. Then width of the seat, that is the buttock width, so this is where you can see, the width is somewhat, the 95% and all that, it is within this range, and the maximum one is this. And similarly, height of the seat, you can see, this is what the dimension. So we could find some of these dimensions are not matching with the seat dimensions, which results in taking awkward posture by the dumper operators while they are while they are sitting. Besides, when they are operating the vehicle, the dynamic posture comes in, which is beyond our scope. So let me summarize some of the conclusions. Based on the DGMS recommendations, several studies, conducted by the research team of IIT Kharagpur in different mines, all mines. So based on our study, what we could find out, the vibration studies to assess the health risk. Moreover, all the machines must be tried for vibration, must be tested for vibration exposure, so that they do not exceed the lower limit, which is given there based on ISO 2631 and amended version. From the vibration study operators, amount of dumper, the something missing here. The dumper operators were found, to be exposed to moderate to high health risk, which requires for an immediate, action. Then the vibration expresses the vibration exposure time for these operators should be reduced, that should be down, and also there will be a scope of job replacement.
You are not audible.
হ্যালো স্যার, অ্যাকচুয়ালি আপনার ইয়ে কেউ মিউট হয়ে গেছেন আপনি।
Sir, you sir open your.
Can you hear me? Can you hear me?
Yes sir.
Okay. So these are the vibration, this thing, which are, the recommendations, based on DGMS, all mines should be carried out. And so far, all the mines we have carried out during the last 10 years, we find in all the mines, may not be 100% of the operators, but majority of the operators, like in the Noamundi mine, the dumper operators, 70% of them are suffering from some type of disorder. Okay. Similarly, the vibration study, that is what we have said. and then they all this mines, they have to carry out ergonomic process assessment. In fact, we did at our Normundi study as part of the causal factor and recorded this. I think that's all done. Okay, thank you. So I have to stop my screen.
Thanks a lot, sir. Very, very informative lecture. This is a
Okay,
great
yes.
pain area in industry, sir. Great pain area. So,
Thank you, Mom.
Sir, I would now hand over the session to Souvik, Sinjana, Ashish. Somebody please take over to the Q&A.
Yeah, thank you, ma'am. Thank you. So, thank you, sir, for this nice lecture. And now we
thank you.
Yes, sir. So we have some queries in the chat box. So let me take the first query.
Yes.
Yes, sir.
Yes.
So first query.
I can see. I think I can see. Mr. Ashish Thakur, right? Mr.
Yes, sir.
Ashish Thakur, please tell. Yes.
Actually, I have sorted out some of the queries. So
okay.
Yes, sir. So first question is, how are you measuring awkward postures? Are you using wearable devices or video analysis to access posture?
Yes, we are doing video analysis. We are capturing through video the entire posture, and then we have a dynamic posture part, and then we have a Ergomaster software which we have purchased 3 years back, through which we can carry out the posture by posture. If we frame by frame, we can carry out the posture analysis and find out based on the REBA, what is the score and all that. And based on that, we measure, they have a chart whereby, you can identify what is the total score, and based on that, you can identify their MSD risk, whether they are, they are having any MSD risk, or they have a moderate type of MSD risk, or MSD risk which is not acceptable. So their maximum score is 7. So that is what it is. So I hope, and static posture, of course, we measure through anthropometry. We told you, and check it with the sit dimensions, and we could find out the sit dimensions are not matching with the operator's physical body dimensions. Okay, so we are carrying out static body dimension measurement as well as awkward posture assessment measurement. We have taken videos, and we upload the video in Ergomaster, and then increasing snaps one after another, and then measure the vibration. Okay, it automatically gives us this score. Okay.
Yes, sir. Thank you, sir. So the next question is during loading operation of dumper by shovel, the operator is exposed to shock or impact vibration, which is very frequent due to high production demand. What are the interventions an engineer at site can come up with to mitigate the effect?
Just tell me, I didn't get it. That's we have a process where 2D cards are pulled. No, it is different, right? Many drivers complain or no.
Yes, sir. That question is, yes, sir. That is different question, sir.
Oh, that is different. Then I think we have a question from the Amit Sharma. Is there any guideline? No, that is not there. Then which one? The operator in Indian mining industry are not open to answer. No, I could not get it. Where is that question? Is it appearing?
No, sir. Actually,
okay. Tell me once again. Let me hear properly.
Yes, sir. Just a minute, sir. So yes, the question is during loading operation of dumper by shovel, the operator is exposed to shock or impact vibration, and it is very frequent due to high production demand.
Yes.
What are the interventions an engineer at site can come up with to mitigate these effects?
Yes, it's a very good question. I appreciate it. So, as you know, when the shovel operators, are, the loading this, the material, whether it is overburden or the ore, it has different sizes of boulders are there. So particularly if the boulders are of small size, then it is not much of a problem. But if the boulders are very big sizes, and then when it goes for its first unloading in a empty dumper, such, big boulders, they causes, huge vibration. In fact, let me cite to you one such problem, as you have raised a very valid question. In West Bukharo mine, one of the dumper operators, he was getting loaded through a shovel, and once the shovel, unloaded the first, pass, then the dumper operators immediately could observe an immediate, shock in his spine, and for a second, he could not move his body. Then of course, after a few seconds, things were all right, and then he was, rest of the dumper was loaded and all that. But when he was about to start the dumper, he could not, move the dumper. Okay, his whole body, he could not move the upper part of the body. So he called his immediate supervisor. Immediate supervisor, took him down the dumper and then took him to the hospital. Then there, the X-ray was done, CT scan was done. In fact, we talked to the occupational physician. Okay, they all were very cooperative. The CT scan was done, but nothing could be detected. Pain was existing. So he was, transferred to the Jamshedpur, the main hospital. Their MRI was, done, and it was found out it was a soft tissue damage, and he could not come to work for 6 months. So there were, around 11 to 15 such cases were there in West Bokaro, which led them to carry out this study. So there are many things we can control this. Let me tell you intervention strategy which management can take. First of all, management can train the operators. If there are big size, because the shovel operators, they can control their machine. If they are, when at the time of uploading, if there are big boulders are there, then they should, take the bucket till the end of the empty dumper, the backside, and then slowly he should, dump the material. All right, he should be given proper, because most of the dumper operators in mines, neither the dumper operator nor the shovel operator, they were aware of this, human vibration or whole body vibration. So, and the expert drivers that we have seen, or they have told, the management informed to us, the expert drivers, they can, do this job very, very cautiously, shoveling time, which usually the whole cycle may be taking 2 to 3 minutes, 3 to 4 passes or 5 passes or 6 passes. It should be carried out very, very slowly, so that it takes more cycle time to complete the loading operation. And, the dumper operator can also take erect posture and all that, to ensure that. So the training for operators should be given, awareness should be brought in, and, the management has to take, proper intervention. Maybe, the machine is too old. All right, machine is too old, so they have to look at how old is that machine, what is the maintenance record of the machine, how is the vibration, all those things, they have to take into consideration. In fact, some of the shovel dumper operators, they say, sir, we get scared when these boulders are being loaded onto our dumper. Okay, so both the dumper operator as well as shovel operator, both have to be trained, and they have to be cautioned, besides this sitting posture and maintenance thing and all other things that I have mentioned. I hope this answers to your question. Okay.
Thank you, sir. Thank you.
Yeah.
Thank you.
Yeah.
So we have one more question. We will take one more question. The operators or workers in Indian mining industry are often not open about answering questions whether they are suffering from the low back pain or any other vibration induced disorder, as they think it might cost them their jobs. So how can we raise awareness in this regard?
Yes. So let me tell you, you have also asked a very, very pertinent question. So, that they do not like to disclose all these things because they feel they may lose their job. So what we did during this question session, during this break time, when they are taking their tiffin in their room and all that, we call it in a separate room where no officials will be there. If you are present there, they will say, no problem, sir. Okay, no problem, sir. We are fine, sir. There is no problem. But if they are not there and if we say your name is not noted down, so then they, answer, we believe they answer, with some accuracy. And obviously, there is a factor which is called social desirability factor that may always be present, but that will be minimized if the management is not there. And if we can first convince the operator the benefit of this study, that it will improve their health. This is very, very important. So our initial briefing, sometimes I also brief initially, how it will help them. Then they open up. They said, sir, इसमें ज़्यादा vibration है, इंडियन वाला जो मैन्युफैक्चरर है, उसका ज़्यादा vibration है, सर वो बाहर वाला बहुत ही है, but थोड़ा सीट का ठीक संभल करना है. They say, they fluently come up with even their solutions. Okay. And then we share with the management, and they agree. It is not that they do not agree, because at Noamundi Mine, their mines manager is my student, Sanjit Adhya. Some of you may be knowing. So they cooperated with us through this entire study very much. And there was another one, Vivek. So he was the coordinator of all. So we get so much cooperation from the mine management, it is unbelievable, unbelievable. And also from the operator. So we are very much thankful to all of them. Yes. Next question is, yeah.
Yes, sir. Thank you. Now the participants can unmute themselves and they can raise the queries.
Okay. Thank you. That is good. I'm happy. Okay.
Yes. So from participant side, any questions?
Hello, sir. It's Ashish Thakur here.
Yes, Ashish Thakur, please raise your voice. Yeah, Mr. Thakur.
So my question is about actually one particular condition in my actually factory.
No, please louder, please. You are not audible properly. Mr. Thakur, can you make this thing more audible?
Hello.
Yeah.
Is it audible now?
Yeah, somewhat improved. Can you put your speaker at 100%?
Yeah, it is already 100%, sir.
Okay. Mr. Thakur, please go ahead. I will try to understand. Otherwise, some of them will help me. Tell me.
Yeah, it is actually a particular case which I actually put in chat box as well. We have actually 2-ton this carts which is pulled by a tow truck which drive on sideway, which means my operator is sitting in perpendicular position from the driving direction. His body is always twisted towards right direction, and many of my operators actually complained about back pain.
Yeah,
we are not able to measure any force on actually this awkward position or any other criteria from where we can actually assess how much this flexion of body is there. So is there any way to measure that flexion or upward posture of operators?
No, we can measure the awkward posture of operators in what I should call it, from that, what I should say, from the video. See, you have to take video, as I told you. Then through this video, you may analyze through screen by screen, and then may look at what are the awkward postures they are taking, in bending position, not in the Z direction but in the lateral direction and all that. Then maybe you can, one thing what you can do is that you can make your chair movable, rotatable. We have a ergonomic chair, which can rotate in any direction. In the forward direction, you can move it up. You can rotate, for example, when in a drill machine, when the operator is driving, is in the operator position and the drill rod is in his right. When he swings, he looks at the drilling, position, whether he's changing with the drill rod, he looks at it. Then the ergonomic chair automatically get towards the drill rod, so that he can observe. So you have to have the ergonomic chair, and also you have to analyze the dynamic posture and see how you can control, or you can teach the operator how to minimize their twisted posture, in order to avoid flexion. Okay.
Thank you very much, Professor. Unfortunately, that cart is very small, and this
I have not seen it. Yeah. Okay,
so
then tell me.
thinking to have actually cars with the tow truck with actually forward direction driving. So that is one of the change we were already thinking. But really thankful to you to give this message to us. So we will certainly consider this. Thank you very much, Professor.
Yeah, at least you can think of moving chair, moving, rotating this thing. At least if it can be. Will it not be possible?
It is not possible, Professor. It is very small, actually, tow truck. If you will see, this kind of forklift.
I see. Okay, I understand.
So, this question is whole body vibration meter can help on measuring that values? Because as you know, that convince management about investing more on new equipment or something. So we need to have some data. So is this whole body measurement will help us to get that numbers?
Yes, obviously. You can measure whole body vibration for any equipment, including our car that we drive every day to our office, or particularly those who are in the, mine site or far off from their, workplace location, and they have to drive a long road when the roads are very bad, or very poor, road conditions. So you can measure, obviously you can measure, and you can see, how your body is exposed to vibration. Then maybe you have to control the speed. You have to be very, very cautious when some ditches or potholes are coming and all that. It is only through education, training, awareness, and through taking proper management intervention strategies, it can certainly help. To minimize the vibration, may not be to control the vibration, below the limit, but at least to minimize the vibration, definitely you can do. And then what process change and everything, Okay.
Yeah. Thank you, Professor. Very helpful.
Thank you.
So, thank you, sir.
Thank you.
Hello, sir. Now, I would like to end over this session to
yes, Amit. Is it Amit? Amit?
Yes, someone.
Okay. Yes, Amit. Go ahead.
There.
Go ahead, Amit. What is your question?
Sir, I have already asked my question in the chat box. You have already answered. Thank you.
Yes, yes.
Okay.
Please.
Sir, I am having some addition.
Okay.
No, it is, I think, Brijesh
Yes, sir,
Mishra.
from IIT Dhanbad.
Yo, Mr. Brajesh Mishra, how are you? How are you?
Sir, I'm fine.
Fine, sir,
Okay,
fine.
okay.
Actually,
Sir, can I ask you a question?
Certainly, certainly. You are most welcome, Mr.
Sir,
Mishra. Let me
sir,
tell
do
you,
you think
Mr.
that
Mishra.
this? Yes, yes.
ah.
Sir, do you think that this vibration study need to be extended to Indian truck drivers? Because I feel that they are the most vulnerable people.
All. In fact, in your Hindalco steel plant, you can use this.
Yes,
Okay.
yes.
You can
Yes.
do that. Yes. Let me tell Professor Maiti that Mr. Mishra has joined our MTech program in safety, health and environment with his vast experience as head of, their Hindalco, the processing plant in health safety division. Yes, yes. Yes, Mr. Brojes Mishra, you can talk to your higher management. We can take up this work under COE. Yes, Mr. Mishra. Thank you.
Thank you, sir. Thank you.
Thank you. Yes.
Yes. Thank you, sir. So
Okay.
now I would like to hand over the session to Mrs. Mitra.
Okay. Thank you all. Thank you everyone for listening to my presentation.
Ma'am?
I appreciate it. Yes.
I will request O.P. Krishna sir to just propose the formal vote of thanks.
Okay, thank you. Professor Ashish Bhattacharjee is a great talk, enlightening talk to
Thank you.
industry people. Especially the industries are reluctant to get into these studies.
Yes, you are absolutely true. I fully agree with you. Yes.
Only progressive industries, progressive forward-looking industries are looking for these things. And also, I always used to think, having involved in all these things, with Industry 4.0, IoT things coming in, data analytics coming in, probably before actually the people get damaged, their bodies, the necessary corrections, necessary suggestions, necessary implementations could be done before actually. You see, I am very clear. Once the body start damaging, disc damages, probably it is irreversible. It's very difficult to
exactly,
set it right.
Exactly. Yes,
so putting proactive right from the day the driver sits on the seat, probably by putting the data and giving necessary action before anything happens, that would be better. I don't know when those things will come. I think by the time it comes, the vehicles will be driverless.
Yes.
Thank you very much, sir.
Thank you.
I also thank you for giving an excellent chairman to us by training him under you in the PhD.
No, it is my pleasant opportunity, and we are all a part of COE ACA, so we'll work together more, Yeah.
See, it is so. It will be very, very. The guru and the shishya both are in the same.
That is what the present opportunity, and chairman is hosting the show. Yeah, that is also.
Sir, Professor Krishna is also in the line.
I am fortunately I am Professor Maiti is my guide. See,
yes. In fact, Professor T.S. Paul was there, I think he was there in the audience. Yes, he's still there. I can see.
Yes,
Professor
sir.
Maiti is his guide, So whenever I go to any selection board, whenever they see anybody is working in safety and all that, and if some person is there, he will say, "Do you know Professor Bhattacharjee? He is the father of grandfather of you. You have done your PhD under father, but he is the grandfather of your father." So,
Thank
So
you. Thank
they
you.
commented this joke. So I
Thank you.
feel proud, I feel proud that Professor Maiti, is now the chairman, and as long as I am there, I will try to put my hand to him and to you all,
Thank
so
you, sir.
that we can achieve the excellence which all our students and the Tata
Thank you.
Steel Group are
Thank
putting
you.
up
Thank
there.
you for your
Thank you.
support
Thank
to
you.
the COE.
Thank you.
And
Thank
I should thank the audience very patiently. They heard, they put a lot of questions to make the speaker very happy. So thank you, audience, and the moderators, Mom, Sinjana, Ashish, and Savik. You are all doing a great job. I know how many Savik sends mails to around 2,000, 3,000 people for attending these sessions. So much efforts people are putting for doing. Sinjana works background for making all these slides. Mom working in the industry, still she is sparing time. Thank you all. And Professor Maiti, I need not formally
Don't
thank
worry,
you.
I'm part of you.
This is your baby, and it's coming up. You should be very
Yes,
happy.
yes.
And thank you all ladies and gentlemen. Thank you very much, and good night. We'll see next Friday again with one more great speaker. Thank you.
Thank you, Professor Maiti. Thank you, Professor Krishna. Thank you,
Thanks, sir.
Mom. Then Sobek and all others who are helping us, to putting up this. Okay, thank you once again.
Thank you, sir. Thank you, all the participants. Thank you, Professor Krishna.
Thank you,
And
Professor.
Mom and our research scholars. Okay, sir.
Thank you, sir.
Okay,
Good night for today.
bye. Good night
Okay,
to all of you. Thank you.